area of a cylinder. So in your notes, this will be formula number 3. Now, because I don't have the visuals that I use in class for this, you'll have to see if you can mentally think your way through this for a second. So what we're going to do first of all is we're going to take the cylinder and break it into its individual parts. All right, so let's take a look at our shape now, kind of broken down into sections. First of all, if we were to break this down into sections, we want to make sure we understand how many pieces we'd need. Well, if you look at our shape, we need a piece of green paper on the bottom, which is circular, the yellow on top, which is circular, and this is where the visual helps. If you were to unroll that blue part, like the label on a can, it just ends up being a large rectangle. So when we look at this, we have 2 circles and a large rectangle piece that would wrap around our cylinder. Now the nice thing about our 2 circles is they're the same, so all we need is one of them, and then we'll double that. It's this rectangular that we're going to have the most trouble with, because according to our shape, we want to figure out what this dimension is and what this dimension is. And that's what we'll see to do. Again, a little easier in class when I have my visual, I actually have a piece of paper that we unwrap, but we'll see if we can get through that. So let's take a look first of all at our circle. We need the formula for the area of a circle, which happens to be r squared times pi. Now that's just one circle. Since we have 2, we'll double it. So there's my 2 circles. 2 times radius squared times pi. Now first of all, before we move on, important to recognize that radius is half of the distance. There will be some problems where they actually give you the diameter. We don't want that. So you want to make sure that when you're starting your problem today that you're finding r. Well, how do you find it? If they give you diameter, you just divide it in 2, cut it in half, because we only want half of that. So number 1 is understanding what r is. Second thing, the value of pi, most of you know, is 3.14, but if not, you may want to write that in your notes also. Okay. So that's the first part of the formula. We have our 2 circles, radius squared times pi. Now comes the paper. If I took this purple piece of paper and I wrapped it around this cylinder, well, this left side is actually showing me the height of my cylinder. So I'm going to refer to this as the height. The bottom dimension is the part that wraps around the can. Now, if I wrapped it around this can, here's my starting point. If I wrapped it around the can, it goes all the way around like this, which is nothing more than the circumference of that circle. So I need the circumference formula, which is 2 times radius times pi. So that's the dimensions of that rectangular piece. The height of the cylinder times the circumference of the cylinder. So there's my 2 dimensions. To find the area, we take the 1 dimension, 2 times radius times pi, and we multiply that times the other dimension. So there's my blue or purple rectangular piece. If I want the total of these, we simply add those together. Now, in most math books, that's the formula you're going to find. However, I think it's a pretty complicated formula. So we're going to try to simplify this formula. So this is what we're going to do. First of all, I started this formula just like I have right there. 2 times r squared times pi. No difference, I had parentheses in mine. And 2 times radius times pi times height. Now I'm going to rewrite this for a second and make this 2 times, I'm going to change this r squared to r times r, and then times pi. Same thing, I just changed how I wrote it. Well, that doesn't make it simpler, it makes it more difficult. So far it is. Times r times, pi times height. So I just rewrote that same formula, except now instead of using r squared, I wrote rr, radius times radius. Now we're going to come back to that in a second. Because what I'd like to do is to take a look at a problem like this such. In algebra, we have something we call factoring. Whenever we have this quantity, and when a quantity, these parentheses, and another quantity, whenever there's multiplication in those quantities, it's okay to pull out things that are common. So instead of using it twice, you really only need it once if it's in common to both. So for example, both of these have a 2 in it. So I could pull out that 2 and pull it outside the parenthesis. They both have a times. I can pull that out. They both have a 3 and another times. So I'm going to pull out the 3 and the other times. And then there's nothing else in common. So I write down with my parentheses the things I still have left. I still had 4 plus 5. Now I'm going to erase all that scribble from that first original problem, and I want to look at those two problems because those two problems are mathematically exactly the same. Now most students would look at that and go, well, the problem on the bottom is a lot easier. Yeah, it is. We've simplified it. I do want to prove that this is the same. So let's check our answers. If I multiplied all these three, 2 times 3 is 6, times 4 is 24. I multiply these three, 2 times 3 is, sorry, 2 times 3 is 6, times 5 is 30. Adding those two together, this top problem is 54. Let's look at our bottom problem. Order operations, this is 9. Now, 2 times 3 is 6, 6 times 9 is also 54. Same answer. Yet we did a problem that was much easier. Is what I'd like to do now is say, can we do any of that simplification to our formula up top here? So let's pull out things in common. Well, I have a 2 times r on both sides. I also have a times pi on both sides. And then I have one little more multiplication symbol on both sides. I pulled out all the things that are in common to both sides, leaving me the set of parentheses with r plus h. We've taken this longer formula that you see up top here, and we've factored it, making it a much shorter formula. Now, the only thing I'm going to do to change the formula and make it a little easier is order of operations. We should do parentheses first. So I'm going to write that first, r plus h. Then we're going to multiply it by what we have here, times 2 times radius times pi. And this is the formula that I would like you to write in your notes. We'll make it down so you can see it a little easier. Right here. Radius plus h times 2 times r times pi. Yeah. All right, now what I'd like you to do is take out a single sheet of paper. On the single sheet of paper, it may help to write that formula out again. Radius plus height times 2 times radius times pi. Now, all we have to really identify in this problem is what is the radius and what is the height. So you look at this circle first for the radius. What's halfway across the circle? Oh, it's 3. What's the height of this can? It's 7. Now all I'd like you to do is to, if you can, stop the video for a second, substitute those values in, and see if you can find the solution for this problem. Meanwhile, I'm going to grab a calculator, and I am going to do the same problem. Okay, sorry, I'm having trouble finding my calculator. All right. Okay, now that we've done it, I'm going to punch it into the calculator. And r plus h, I've got two things. I can actually punch that into the calculator, or if it's easier just to add them in my head and put in 10, you can do that. So 10 times 2 times radius, which is 3, times 3.14. And the answer to this should be 188.4 inches squared. Okay. All right, I'd like you to try one of those completely on your own and see how well you do with this problem. Then you can restart the video and watch its solution. Okay, now that you've had the chance to solve this problem, there's really two answers that I see predominantly in class. 56 point something feet squared, and I'm not really too worried about the decimal because some students are using pi 3.14 and some are using the pi button. And then I also have about a little over half the class, they have 24 point something feet squared. Predominantly the two answers I'll see. Now, unfortunately, only one of them is right. And the one that's right is this second problem. So if you had 24 point something feet squared, great job, you did the problem well. If you had 56 point something feet squared, not that it's an awful job, you followed the formula correctly. The problem was you didn't identify your r and your h correctly. So let's make sure you did that. Radius is halfway across the circle. Here's my circle, and I only want halfway. In the problem, they give you all the way. So you had to divide that by 2. So the radius you should have used is 0.8. If you use 1.6, then that's where you found your mistake. If that's the radius, then here's our height of 4, and plugging those values into your equation or into your formula should have given you 24 point something square feet. Assignment for today is in the math book for the blue classes, page 539, numbers 3 through 11. For those in the green books, the accelerated classes, there is a copy of this worksheet or this page attached to my web page. So you can download or print out a copy of that page also. You can also access the blue book online if you would like to access that blue book.